now let's talk about quantum numbers. So by definition, what are quantum numbers? So quantum numbers are defined as numbers that are used to describe the distribution of the electrons in an atom. So for you to understand quantum numbers easily, I have come up with a certain analogy to help you understand the main idea behind the quantum numbers. So now we've said that they are used to describe the distribution of the electrons, right? So a realistic example that I can give you is that imagine there is a guy called let's call him Jacob. So suppose I want to describe the location of Jacob. I want to be more specific. I want to describe in such a way that I specifically describe where Jacob resides. So let's say Jacob is, first of all, is found in the continent called Africa, right? So we are going to say you can find Jacob in Africa. But again, in Africa there are many countries, right? Now which country in Africa? We say we are going to find Jacob in Zambia. Again, in Zambia we have about many provinces, right? If I just say that I stay in Zambia, you won't know exactly where I stay. So I want to specifically describe the location of Jacob. So I'm going to say that in Zambia, Jacob stays in Copper Belt. But again, in Copper Belt, in Copper Belt province, there are many districts, right? So to be more specific, we are going to say that Jacob stays in Kitwe district, right? But again, in Kitwe we have different, a lot of areas, right? If I just tell you that I stay in Kitwe, maybe you're going to have a bigger idea, but you won't know where exactly. Okay, so let's say in Kitwe, Jacob stays in Copper Street. So now let's say you come to Copper Street, then you're like, now where do I find Jacob? You still won't know where to find Jacob, right? Because there are a lot of houses in this area called Copper Street. So to find the specific location of Jacob, you need to know at least the house number, right? Let's say the house number 1843. I'm just coming up with some random house numbers. I don't know if there is I don't know if this is the format of the house numbers. I'm not sure. So now in this house, a house having this house number is where you're going to find Jacob, right? So you're going to find Jacob in the house. So have you seen how I've just described the location of Jacob? This is also how we describe the location of an electron in an atom. Okay, you know that an atom can have as many electrons as possible, right? So now when you're describing the location of an atom, the location of an electron in an atom, we don't use we don't use these words. Okay, we don't represent everything in words. No, we represent using quantum numbers. Okay, instead of me having to say no, at this location, at this level. Have you seen the hierarchy that we are following? We are breaking it down, okay, from the high level to low level till we find the specific location of a person, right? So till we find the house where Jacob resides. So now even the electrons, we follow the same format or the same technique. I don't know if I should say the same hierarchy. Now let me show you how we describe the electrons. So have you seen the structure Okay, the hierarchy that we've been following. I started with the province, right? I mean, the continent, then the country, right? Then the province, right? And then the district, right? And this was the, let me just say, residential area, the house number. Okay, till we find a person, right? So even when you're describing an electron, listen, there'll be many electrons. So now we'll be using quantum numbers to only describe the location of a specific electron. Okay, we'll be describing one electron at a time. So now let's see the hierarchy that we can follow if I wanted to describe the electron. Okay, so first of all, you need to understand that an atom, which is represented by a circular shape like this. I know it's not gonna be perfect because I'm using my free hand, but let me try my best to draw a very sensible circle. Okay, yeah. So an atom has got a nucleus, right? Then the what are called the orbits. They are called the orbits. They are also called the shells. They are also called the energy levels. Let me show you. They look more like the orbits around the sun, but these are orbits where you can find the electrons. I think, let me at least have maybe about 4 or 3. I'm just trying to give you a picture, okay? Before I start explaining, I just want you to have a picture about these. Okay, so this is a nucleus here, and the electrons are found in these. These are called the energy levels. Look, they have different names. Let me write here. So they can call them the orbits, not the orbitals. They are different, okay? They can call them the orbits, or they can call them the energy levels. They can call them what else? The shells. So if they use any of these words, they are still referring to the same thing. So this one is the first energy level, or same orbit, or same shell, which is the first shell, right? This is our second shell. This is our third shell. This is our fourth shell, right? So the electrons are found in these shells. Okay, so in the energy levels is where you're going to find the electrons. Now, how are the electrons distributed? How are they oriented in the atom? This is an atom, right? According to Bohr's model, this is an atom. So if you remember the hierarchy that we are following when we were describing the location of Jacob, we are starting from the bigger picture, right, to a smaller picture. I don't know if that's the right way to explain it. Now, for the electrons, at first you have an atom, okay, and then inside an atom, you have got what you call shells. Shells, which are what we're seeing here, right? And then in these shells, they are what are called the subshells. The subshells. And then inside these subshells now, we have what we call the orbitals. Okay. So if you remember when we're describing the location of Jacob, we started from the continent, right, which was the bigger picture. Then we went to the country, right, which is the smaller picture. Then we went to the province, right, then district, till we went to the plot number, right? Yeah. So now, plot number, we find like house number. I don't know if I should say plot number or house number. So house number, we're referring like to a house where we can find John. Okay, this is more like a house. I mean, not John, Jacob. That was the name, right? So in the house is where you're going to find Jacob, right? So the same way we were describing him, even the electrons, they are like that. Now for the electrons, in the orbitals is where you're going to find the electrons. Okay, is where you're going to find the electrons. So the orbitals, they are drawn like this, depending with the subshell. Each subshell has got a certain number of orbitals that it can have. We are going to look at that in a minute. So it can have 1, maybe it can have 3, okay? So it depends with the orbital, with the subshell. What to determine the number of orbitals? This in the orbitals is where you're going to find the electrons, okay? Is where you're going to find the electrons. They are represented like this, which we are going to look deeper. We'll start looking at the electronic configurations and stuffs in order to draw the orbital diagram. So this is what we call the orbital diagram, okay? It represents like it just shows how the electrons are organized, okay? How they are arranged inside them, inside the orbitals, or inside them. Yeah, since we're talking about the orbitals. So in the orbitals is where you're going to find the what? The electrons. So have you seen from the bigger picture to the smaller picture, from the high level to the low level? So we can call this an hierarchy, right? Yeah, it's the most appropriate way to use here. You can call this an hierarchy. So now that you have a clue, let's look at now how we can be describing, okay? Remember, we won't be saying that, no, the electron is in the second shell by writing like words. Or we won't be saying it's in the second subshell or the first subshell, or it's in the first orbital, second orbital. And actually, we even describe deeper for electrons. We will even be describing how the electron is. Have you seen? The electron can either be like this or like this, okay? So there is a way to describe whether it is pointing upwards or downwards, not by saying upward or no. We use quantum numbers. So quantum numbers are what we use to describe the what? To describe the distribution. I think is the most appropriate because we are also going to see how they are distributed. But I think the sensible one is to say the location of an electron. So we use them to locate. It's more like to locate something, to locate an electron, because the quantum numbers will like direct you to a specific electron. I can describe this electron using quantum numbers. I can describe this one. I can describe any electron, okay? So they help us to describe, okay? So the reason why I'm teaching you this is that so that when I start explaining, you already have a clue, okay? So the orbitals are like the house. The same way you stay in the house, electrons also have got a confined, some sort of a confined area, environment. I don't know if the appropriate way to use, but it's more like a house where they also stay, okay? And they can either point upwards or downwards while they are staying there, okay? And these are called the orbital diagrams. Orbital diagrams. So I'm sure by now things have made sense. If you're somebody maybe who's struggling, so just have this image. Once you just have this image, like you just understand this, you never struggle to understand quantum numbers. If you find somebody saying that quantum numbers are very hard to understand, just know that they don't understand this. This is the main logic behind this topic, okay? Now, let's look at the quantum numbers. So we have a variety of them. So let's say the types, I don't know if I should say categories or, yeah, let me just use the word types of quantum numbers. So now, what are some of the types of quantum numbers that we have? So we have the first one. The first type is called, or they are called, the principal quantum numbers. Now, what are these principal quantum numbers? First of all, before I even proceed, you need to understand that the principal quantum numbers, they are denoted by the letter n. So whenever you see the letter n used anywhere, just that they're talking about the principal quantum, or just know that this is a principal quantum numbers. I mean quantum number. So now, I'm sure these, for these you are familiar, right? If you've understood the introductory part. So the principal quantum numbers, they represent the shell, the energy level, or the orbit, okay? For instance, let's say you have I know the circles aren't perfect. This is the nucleus, this is N1, this is N2, this is N3. So now, this is a quantum number here. It represents the first what? The first shell. N2, the second shell. N3, the third shell. Okay? So, they represent the energy levels. Apart from that, you can also say that they also kind of like represent or describe the average distance from the nucleus. By just saying that, maybe if I just tell you that the electron is having the principal quantum number of 3, or maybe if I were to say that the electron is found in the shell, which is the third shell, you are going to know that it is here, right? And you are going to maybe approximate the distance that it is from here to where? To here, right? And if I tell you that it is in the second shell, maybe it is here. You can also approximate the distance from the nucleus, right? So now, have you seen this distance is longer than this one, right? The displacement is larger than the displacement for this one, right? So you can even tell that the higher the energy level, the further it is from the nucleus, right? So by that you can even know the distance. You can know that this is more further than the other. Okay, this is more closer than the other. So it also represents the average distance of an electron or of a shell from the nucleus. Okay, so that's one of the important concepts you need to know. So that's it about principal quantum numbers. This is it. Okay, there's nothing complicated here. Let's go. We go to 2. So now let's talk about the angular momentum. Angular momentum numbers. So for these you need to pay a lot of attention, okay? They are not hard, but they are very important. You need to understand them. So we have the angular numbers. So the angular numbers are represented by L. In some books, they represent them by E, the letter E. They are denoted by the letter E. Now, I won't be using this because they are oftenly represented by L. Okay? I don't know if it is L, but they write it as L, like L. So just writing letter L. In some books, they use E. Okay? So, these angular numbers, in some books, they tell you that they represent the shape, something like the shape, right? But the general description for these, I would say that they just describe the subshells. They just describe the subshells, and they also depend on the principal quantum number. So let's say you have the principal quantum number of n. N is equal to 2. So for you to find L, you need to use the formula, which is n minus 1. So L is going to be what? 1, right? So like in this case whereby they have given you the value of n, or the principal quantum number, you need to subtract 1 from what you have been given, and then what you do after that, you are going to start from 0 to the number that you've gotten after subtracting 1 from the principal quantum number. Okay, so I'll end at 1. So if they have given you n is equal to, so these numbers you're seeing, they are representing the subshells. Here we are talking about what? The shells, right? We are talking about the shells. So have you seen, we're just like trying to go to break down the hierarchy, okay, from atom to shell, from shell to subshell. So they just so this is the shell, this is the shell. I mean the subshell, not the shell. This is the subshell, this is the subshell that are under this shell. The second shell is having 2 subshells, which are represented by these numbers, which are angular momentum numbers. So they represent the subshell. That's the most appropriate way to describe them. So let's say my n is equal to 3, meaning that I'm in the third shell, right? So my shell is shell number 3, or the energy level number 3. So if I wanted to find in this shell, how many subshells are there? Because we break them down like that, right? If you understood the hierarchy that I explained. So I'm going to say n is equal to 3 minus 1. What number am I going to get? I'm going to get, actually, this should be now L. I'm trying to find the angular momentum numbers. So I'll say now L is equal to 2. So this means that I'm going to start from 0, 1, 2 to the number that I've gotten after subtracting 1 from the principal quantum number. So these numbers that you're seeing, these digits, each digit is representing a subshell. Does that make sense to you? Now, you want to be representing the subshell like, no, this is subshell number 0, subshell number 1, subshell number 2, number 3, number... No, it doesn't work like that. So it works like this. Each digit that we get, and always remember, start from 0, okay? This is like a pattern that they follow, that is followed. Let's say you get, after you subtract from 1, you get like, you get any number. Start from 0 to count till you reach that number, then that is the number representing the last subshell in that shell, which is represented by n, in this case 3, in this case 2. Makes sense, right? I'm sure by now you know how a shell, this is the shell I'm talking about, this is the shell. Inside these shells, each shell is having subshell, then in the subshells they are what? They are orbitals, then in the orbitals they are electrons. I hope you're understanding. So now, I'm saying that each digit that you get, each digit is represented by a certain letter. They also call them as the name of I think of the subshell, something like that. So you need to know that. Let me try to come up with a table. So look, let's say here I'm having 0, I'm having 1, 2, 3, 4. Let's just end at 5. But oftenly they don't even give questions reaching maybe as far as, I think the maximum oftenly will be maybe 3 or 2. They don't really reach A, just for educational purposes. So now, each number is represented by a certain letter. Okay, 0 is represented by the letter S. 1 is represented by the letter P. 2 is represented by the letter D. 3 is represented by the letter F. 4 is represented by the letter G. 5 is represented by the letter H. So instead of you having to say that this is the subshell number 1, or mean number 0, subshell number 1, number 2, no. You'll be using numbers, these letters to represent. Okay? Now, how do you represent? Let's say I want now to describe, let's say I know my shell, right? Let's come to this one. I know that I'm in the second shell. I want to describe the subshells that are there in this shell. You know the fact that there are subshells in the shells, right? Yes. So you are going to do this. In front, you are going to put, I think, let me say, you put in front in the number of the shell or the energy level, then followed by the letter representing the what is this, the angular momentum number. So I think I'll just say L, but don't use the number, use the letter. So let's say I want to describe this. I know that these are the subshells, right? First subshell, second subshell, first subshell, second subshell. This is the third subshell. So let's first describe this. So I'm going to say first I'll put n. What is my n? Let's start with this part. My n is 2. And what is my L? Is 0, right? My L is 0, which I got after subtracting. When we initially subtracted 1 from this 2. That's why we are putting 2, because all these are as a result of subtracting 1 from the value of n. So n will still be attached to them, but it is always going to be in front. Now 0 is being represented by s, right? So I'm going to put 2s, and then followed by 1. Now in front again put 2, because 2 is their shell. Then here now you're going to put, don't write 1. Which letter is representing 1? It is P. Have you seen? So you have just represented, this is a shell having, so this A is a subshell. Have you seen? How it is making sense at the moment. So now let's come to this. So this, our n was what? 3, right? I subtracted 1, then I got 2, right? So all these numbers that I got, I've already explained how to come up with this. Where as a result of subtracting 1 from n, right? So the value of n representing the number of the shell, it is going to be there when I start describing the subshells. So I'm going to say, first I'm going to write 3. I'm here, which is representing the what? The shell or the energy level. Then I'm going to say, I'm going to now represent the 0 that is here. 0 is being represented by which letter? Letter S, right? So I'll put S. Then I'm having 1 here. So now 1 is being represented by which letter? Letter P, right? So I'm going to say 3P. 2 is being represented by which letter? D, right? So I'm going to say 3D. So one of the things that you need to know is that whenever you see, actually what we are trying to form this one, this is called the electronic configuration. It also shows the distribution of electrons. Yeah. So the moment you see anything written like this or an electronic configuration, whenever you see that we are having same letter, same number in front, just so that all these are falling under the what? Under the same subshell. All these having 2, under the same shell. My bad. I don't know why I'm mixing them. So they are falling under the same shell because 3 is the same, meaning that they are all under these subshells, or the electrons that are there in the subshells, they are under the third shell. And when you see here, you see that in front we are having same numbers. That's why they are under the same shell or same energy level. Like in this case, we have 3. So meaning that they are all in this one. All the subshells are in the third one here. And when you see there is 2, they are all in the second one, which is here. I hope that makes sense. Yeah, so this is all you need to know about the angular momentum numbers. I don't think there is anything to complicate here. Yeah, it's just as simple as that. So let's proceed now. Let's go to the next type of quantum numbers that we have. So far we've by now we know how to describe the shell, right? Instead of you saying no in the second shell, we just use the principal quantum number. And instead of you having to say no, we are having 3 subshells. We are having the first subshell is you are using words. Just write this, okay? This is how we communicate as scientists. We are all scientists here. As long as you are learning chemistry, you are a chemist, and that makes you a scientist. Okay, so let's proceed now. So let's look at the magnetic quantum numbers. So now, so far we've talked about the principal quantum numbers and the angular momentum numbers, right? And I'm sure you've seen that the angular momentum numbers, they depend on the principal quantum numbers, right? Because for us to know maybe the number of subshell, we need to at least have an idea about the value of n, right? Or the principal quantum number. Now, for the magnetic quantum numbers, they depend on the previous one, the angular momentum numbers. That's where they depend on. Now, what are these used for? So they are used to calculate the number of orbitals. The number of orbitals that are found in each subshell. I'm sure by now we know that you can have something like this. We can have something like this, right? Or we can have something like this, which is an electronic configuration. Yeah, you need to be familiar with these words. 2p. Okay. So now, how do you know that in this one, there will be this and this number of orbitals? Orbitals are like the houses, right, where the electrons stays or dwells, and then these are all subshells. Now, suppose you want to know the number of orbitals in each, in the one having S, P, and D. That's why your focus should be not on the number coming in front. Your focus should be on the angular momentum number, this one. So now, how do you know? So there is this concept, and actually the magnetic quantum numbers, they are represented by M with small letter LA, capital letter M, small letter L. I don't know if it looks like C, but it is L. So what you do is that, suppose let's take the first one. We take this subshell 3S, but my main interest will be on the S, because the S is representing what? It is representing the angular momentum number, which is what I'm interested in. Okay, so now which number? Now here we want now to know the number representing S, like which angular momentum number is represented by the letter S. It is 0, right? 0. So if there is 0, you get this 0 and you say this is your L. Now, to find the number of orbitals, you're going to use this formula, which is 2L plus 1. Plug your L here, and whatever it will give you the number. And I think there's something I was supposed to explain. So the magnetic quantum numbers do not only tell us how many orbitals we are going to have, they also give us a number representing each orbital. Like it will give like it's more like a plot number to each house. Okay, now it will give you like each number, a specific number to each orbital found in that subshell. Apart from giving us the number of orbitals, it's also going to give us the number of each orbital that is there in the subshell. Don't worry, you're going to understand. Yeah. So this formula, first of all, is to find how many orbitals are we having in the first one. So put 0 here. So if I put 0 here, there will be 0 here, right? Plus 1. And there will be 0 plus 1. You're going to get 1. So meaning that this just tells us that whenever you have S, okay, no, even if there was in front, they can be, look, it can be in any subshell, I mean in any shell. It can be in the first shell, second shell, fourth shell, the 100th shell. In whichever shell, S is always and will ever be having 1 orbital. This is always, like, it's mandatory, okay? I'm just trying to show you where it comes from so that you can easily remember, in case maybe you forget to memorize, okay? So S only has got 1 orbital. Let's go. What if maybe we take 3p? We are only interested in what? In p, right? So let's say if I were to ask you which number represents p, p is represented by number 1. Take the formula and then we say 2l plus 1. Why does l put 1? It's going to give us what? 3, right? This tells us that whenever you have p, whenever you have the P subshell, whenever you see there is P, because look, this is very important when you start drawing the orbital diagram. They always bring equation involving drawing orbital diagrams. And for you to be able to draw, you need to know these. Okay, you need to know the number of orbitals found in each subshell. You need to know this. So this just tells us that whenever you have P, whether it is 2P, 4P, wherever there is P, P is going to have 3 orbitals. Okay, orbitals. So here we say orbitals. I know the handwriting is not that perfect, but at least try to focus more on the explanations. Yeah, so now let's go to D now. I think now let me just be taking the letters. So now I just want to show you that whether you have 3 or 2P or whichever, so the principal number which is found here in front, it doesn't have an impact on the magnetic quantum numbers. It doesn't. What has an impact is the angular momentum numbers. That's what it depends on. Make sense? So now what if maybe you have D? Maybe let's say 4D. So you just take this one and say which letter represents D. D is represented by letter, let me do this, by the letter 2, right? When you take the formula 2L, this is our L. This is our new value of L. This here is our value of L plus 1. So 2 plus 1, 4 plus 1, 5, right? So mean that whenever you have D, D will always be having 5 orbitals. Makes sense, right? 5 orbitals. Let's proceed. I'm sure you are enjoying this. If you are not, then I don't know what's wrong with you. So let's go. We have D. So no, we've talked about D. So let's go to F, I think. So using the same pattern, you can find for any. Okay, you don't need to memorize anything. Just the formula is enough. So I'll take my F. Let's say maybe you have like 5F. You take your F. 5 is like representing the shell, which does not have an impact on the magnetic quantum numbers, right? It doesn't. So what is our F? Our F is represented by the number 3. I'll use the formula 2L plus 1. Why this L? I'm going to put what? I'm going to put, this is my L, okay? I'm going to put 3. Then you say plus 1. So 2 times 3 times 2, that is going to be 6, 7. So whenever you have F, always draw how many? Always draw 7 orbitals. Make sense? Let's go, let's go, let's go. I'm sure now I don't need to be showing you everything. Let's just quickly find for G and H. Then I conclude under, I look at another part under the magnetic quantum numbers. So let's go. You have C. Let's say you have 6G. So whenever you have G, G represents which number? Which would be our L. G represents 4, right? So I'll use the formula 2 times 4 plus 1. We are going to have 4 times 2, 8, right? Yeah. Yeah, it is 8. Okay. 8 plus 1. That is 9. So what if maybe you have, so have you seen, whenever you have G, in case maybe your lecturer reach there, but often they don't reach there, maybe at D is usually the maximum, okay? In the question that they give to draw the orbital diagrams, they'll be giving you up to D, oftenly. These I'm just trying to maybe, in case, maybe the syllabus might change, maybe they might want to bring, maybe, for the sake of cases, in case of any cases, yeah. So let's go. What if maybe you have H? H is represented by 5, right? So I'm going to say 2 times 5 plus 1, 11, 9, 10, 11. So another pattern I can show you is that, actually first let me conclude. So I'm going to draw a very simple box. A very simple box. So we have a very, very simple box here. So whenever you have, I'm just trying to sum up everything here. So whenever you have s, you have one orbital. Whenever you have what? Which one is that? Whenever you have p, we have 3 orbitals. Whenever you have d, you have 5 orbitals. Whenever you have f, where is our f? We have 7 orbitals. Whenever you have, our last one is g. No, it is h, right? Whenever you have g, you have 9, right? And whenever you have 11, no, whenever you have h, you have 11 orbitals. So have you seen? This is the pattern that is here. Now there is a pattern that is here, like you don't need to memorize anything. So just memorize like the flow from S, P, D, F, G. They just increment, or they increase by 2. 1 plus 2 is 3. 3 plus 2 is 5. 5 plus 2 is 7. 7 plus 2, 9. 9 plus 2, 11. Have you seen? So it's up to you if you'll be using the formula, but this is important. Like you need this, whether you like it or not, you need this. So it's up to you whether to memorize this table or to memorize this formula or to just master the pattern. Yeah. So me I just used to memorize the pattern. Yeah, because I don't know. It's up to you. Okay. The pattern that I've just shared with you, like the one whereby they are incrementing by 2. I just observed it. I was like, oh, so this is how it goes. There is a pattern here. You know, sometimes you need to be observing a pattern. I once memorized the periodic table from I think 40 elements using the pattern. Try to be coming up with patterns when you're memorizing. Like try to see the flow. Yeah, I memorized the periodic table in order, the elements together with their valences. I don't know, back then I didn't know how to find the valences without memorizing. So I just memorized the periodic table, the first 40 elements. Now I've even forgotten the pattern, since right now I don't need them. Okay, so let's proceed. I'm sure you have understood one thing. Okay. Now I think let me also bring in another concept here. I know it when you are reading other books you won't find it here, but I'm going to bring it under the same concept that I'm talking about here. So what they do is this: they are going to bring a question and they'll ask you. Maybe they are going to give you like maybe they are going to say they are going to give you an element, okay, or maybe they'll give you an electronic configuration. Maybe they'll give you like 1s, 2s, 2p, and they'll ask you, maybe they are going to anyways, let me try to make it simple for you so that you understand. So what they do is that they'll ask you if maybe n is equal to 3. I'm trying to make it simple for you now. Okay, I want you to start from here. Like now, I'll confuse them now. So they will give you maybe like n is equal to 2. Okay, maybe they will say maybe they will talk about the third shell or the third energy level. But whatever they are going to say, since I've already taught you all the terminologies they can use to confuse you. Okay, everything they can do to confuse you, I've already prepared you for it. So they can give you that n is equal to 3. Then they ask you now, find the total number of orbitals. Have you seen? And then after that, they also ask you that find the total number of electrons found in this in this shell number 3. And they want you to show your work. Sometimes they would want you to show your work, or they wouldn't want to show you the work. Okay, so I'm going to show you both ways. There is a shortcut because you'll be in 2 scenarios, but maybe there is just 1 mark. They just want to see like if you are able to apply what you learned. So I'm going to show you 2 ways. So let's go. Let's see. Let's look at the first way. So now listen. They have given you that n is equal to 3. So I know you in your thinking you'll be like, if n is equal to 3, I'm going to first find my, according to what I've taught you, I'm going to first find my angular momentum number, right? So I'm first going to say my L is equal to n minus 1. L is equal to 3 minus 1, that's going to be, it will be 2, right? then I know that, okay, now that I know my L, or I know my, okay, let me just say we found our value. Now we need to find the subshells, right? I know my shell, so I need to use the angular momentum numbers to find my subshells. So to find the subshells, you'll be like, okay, so since I'm having 2, I start from 0, 1, 2, right? Then you'll be like, okay, which one represents 0? It is S. 1, P, right? This is D, right? So then you'll be like, now to represent, to come up with an electronic configuration, I need to put the N in front, right? So you'll be like, okay, I'll say 3S, 3P, 3D. Have you seen? Then you'll be like, okay, now I have my subshells. I know I have 3 subshells. And Joseph told me that maybe if you want, you are even going to use the magnetic quantum number. For this one, you say this, you use that formula, right? Yeah, or whichever way you're using to remember. But remember that, okay, Joseph said that this one has got 1, and this one has got 3 subshells. First, at this time, we are trying to find the, orbitals. We are trying to find the orbitals. So I know that this one has got 1 orbital, 3 orbitals. D, we said it has 5, right? 5 orbitals. And they want me to find the total number of orbitals, so I can just add them, right? And I'm going to get 5, 6, 7, 5, 6, 7, 8, 9, 9. You are like, yes, I found it. Of course, if they told you to show your work, you are right. This is the, actually, it's still right. There's nothing wrong. There's nothing wrong here. So now, there's a short way now. Maybe if maybe you are in a case whereby maybe you have multiple choice, or they just want you to write the final answer. There's maybe just a half mark, because you can't show all this work for a half mark, or maybe possibly a 1 mark. So there is a formula. Just say n to the power of 2. It will directly give you the number of orbitals. What is my n in this case? My n is 3. 3 to the power of 2. 3 to the power of 2 is 9. Have you seen? This is like you are using a long cut, then this one you are using a shortcut. So it's up to you. And maybe another emphasis I will put is that don't ignore this, because maybe in case maybe what am I trying to say? I'm trying to say that in case maybe you've made a mistake, this can help you to verify your answer. Maybe let's say you've miscalculated, maybe you've wrote a different answer. You can use this one to confirm. Is the formula giving me the same answer? Then if it isn't, then we know that, I need to double check my work. Probably I've made a mistake somewhere. Makes sense, right? Now, let's go to the number of electrons. So now, I've showed you the shortcut. So take note of this one. Whether you like it or not, take note of this one. Write it down. A lecture, I won't show you this. A lecture, I want you to suffer. I always say this if you watch my lessons. Lectures want you to suffer. They want you to go the hard way. Yeah, they don't want to show you this. Yes, they know. They know all this. But they won't show you. They just want to see, are you able to apply all the notes that I taught you? But again, some lectures are strict. So just show your work, okay? But use this one to verify your answers. I'm not trying to promote laziness. No, me, myself, I'm not lazy. If you've been watching my lessons, you can see that I'm not lazy. Like, I study, I go deeper. I don't use shortcuts. That's why I'm even able to teach you right now, because I don't take short paths. Of course, I take short paths, but not as, I don't prioritize them. It's just like another, okay, let me not speak too much. But I just like shortcuts. Maybe what I do is this: when I'm studying, I don't rush to shortcuts. I'll first maybe like go deeper, then learn the shortcuts now, so that I can now see like where can I use them, where can they work perfectly, where maybe can I save most of the time. Okay, instead of me having to use the long procedure when there is even a short procedure which still can give me marks. Okay, so you need to be strategic. Strategy is everything in your studies. Strategy is everything. Okay, so I hope you're getting now. So maybe now let's find the electrons. So you are going to say, okay, since I know that I have, let me try to draw the orbital diagrams. So since this one has got 1, it's going to have 1 orbital diagram, right? So you're going to say the orbital diagram for 3s is this one, 3s. And for the second one, for 3p, we said that 3p, p has got 3, right? So I'm going to say they need to be attached to each other. If they are found under the same subshell, they need to be attached to each other, okay? They need to be attached to each other like this. So this represents what? 3p, right? Let's go. And in a case whereby oops, what am I doing? So let's draw 3D. So we need to draw 5 of them that are attached to each other. 1, 2. Should I also consider this to be, let me just consider it to be as my subshell. 1, 2, 3. I mean, as my orbital. 1, 2, 3, 4, 5. Right? So you're going to say 3D. Have you seen? So maybe you are going to say, okay, now let me count. 1, 2. Since each box, each house, or each orbital, it accommodates only 2 electrons. So the possible number of electrons that this can have, it will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. We even conclude 18 electrons. Of course, if they have told you to show your work, or you're in a situation whereby you are required to show your work, do this. But the shortcut is this. Since you already know your n, just say 2n power 2. What is our... This is going to give us 2 times 9, right? And it's going to give us 18 electrons. Short procedure. Short method. Have you seen? So now, I've only talked about the part where we use the magnetic quantum numbers to find the number of orbitals, right? And you've seen how it can apply it. Now, did you know that those orbitals, let's say, look at the subshell, maybe subshell 3p. This is a subshell, right? P is represented by which one, right? So this is my L, right? Now, you can, okay, and we say that P accommodates only one orbit, can only have one orbital, right? And accommodates 2 electrons. No, we said it is 3. 1 is the one that has got. Yeah, when you plug in the formula, so it's going to be 3. Okay. So we know that P subshell, it can only have 3 orbitals, and each orbital can have 2, right? So now, do you know that each orbital, which is like a house, right? We've seen that the electrons here, which are arranged like this, it's like the house. It's like that house where you stay. You stay inside the house. And each house has got some sort of a plot number or house number, okay? So even each orbital, we can give it a number. Now, how do you give it a number? So what you do is that get your L, or get your angular momentum number. Like in this case, it is 1. Draw a number line. Put 0. Start at 0. So now, what you're going to do is that you are going to move, first you're going to move to the negative side till you reach where there is negative, the number that you have, or where there is -1 in this case. And you're going to also move to the positive side till you reach where there is positive. Here you have positives, here you have negatives. Till you reach where you have the positive of the number that is here. So at first I'm going to move this side. So I'm going to, and you move in counting numbers like 0, 1, 2, 3, 4, not in decimals, no. So I'm going to say, what comes before 0? Which counting number comes before 0? Which is not a decimal. It is 1, right? And it is negative. So I'm done. Just stop from here because you've already reached where there is 1. In this case, it is negative. Now also go to the positive side. And then, when you go to the positive side, you're going to ask yourself, what comes after 0? That number should not be a decimal. It should be like a whole number. You're going to say plus +1, right? So you have -1, 0, +1. So this will be for the first orbital. This will be the number for the first orbital, the number for the second orbital, the number for the third orbital. So I'm going to put -1 here. I'm going to put. Okay, so this is having the orbital number. Have you seen? The same way your house has got a house number or plot number, but it has got this number that represents it, right? Yeah. So now let's say maybe this time we had maybe let's say we look at D. D is represented by which angular momentum number? D is represented by 2. And you know that D accommodates, it only has got 5 orbitals, right? Now, how do you find the plot number, or how do you find the orbital number for each? So what you do is that, so you're going to draw some sort of a number line. I'm just using the number line to help you understand, okay? Then you see I have 2, so I have to move to the negative side till I reach where this 2, which is negative. So which numbers are going to be between? Before I go to 2, first I'm going to find 1, right? That number should not be a whole number. Then I'm going to find -2 finally. Then if I also do the same thing to the positive side, I'm finally going to have these numbers, which includes -2, -1, 0, 1, 2. So have you seen? Try to count them. 1, 2, 3, 4, 5. Have you seen? So I'm going to get, so this one is representing the first what? The first orbital, the second orbital, the third orbital, the fourth orbital, and the last orbital. Have you seen? So maybe let's say if your L was maybe 4, that means that you are G, right? So you would say, okay, sometimes you don't even have to use this. I'm just using the number line to help you understand, okay? Yeah, I'm just using this like I just made it up. Like I think for them to understand, since everybody knows the number line, right? You learned this in grade 1, 2, 3, 4. I don't know, back there in I don't know if it's primary school or for you guys. Anyways, let me talk much about that. Let me not talk much about that. Yeah, so you use a number line. So in this case, I'm just going to, if you want, you can just say, okay, I have 4. Let me start from -4. Let me start increasing. Let me start from -4. Then increasing, I'll be increasing until I reach +4. So I'll go -4, -3, -2, -1, 0, 1, 2, 3, 4. So how many do we have? 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9. We are having 9, right? And we say that G, if you use that formula, G 2L, so here I'm putting 4 plus 1 will be 8 plus 1, 9. So you're going to draw how many orbitals? These are what we call the orbital diagram. 1, 2, 3, 4, 5, 6, 7, 8, and 9, right? So each one here, this one is going to have -4, -3, -2, -1, 0, 1, 2, 3, 4. Have you seen? This is how it goes. So I have more details now. If I wanted to describe an electron, I can describe starting from the shell which it is in. I can describe starting from the followed by the subshell that it is in. Then I can also describe the orbital, right? Yes. So have you seen? We are breaking down the hierarchy. Remember the hierarchy. Remember. Actually, I think let me first teach the last part. Then I show you now. I put everything together. Okay. Don't worry. I'm here to make things easy for you. So let's proceed, guys. Let's see the last part, the spin quantum numbers. You know that here we have electrons, and an electron can either point upwards or downwards. Each orbital only accommodates two electrons. Let's look at the spin quantum numbers now. Okay, so we have now the spin. look, we have the spin or the electron spin quantum numbers. Spin quantum numbers. Okay, so you know that the electrons in the orbital can either point upwards or downwards, right? So the spin quantum numbers, they help us to describe whether it is pointing upwards or whether a specific or a certain electron is pointing upwards or downwards. So if an electron is pointing upwards, it is represented by the spin quantum number of 1/4. 1/2, sorry. So this is when it's pointing upwards. And then when it is pointing downwards, it's represented by -1/2. Now, where are the negatives coming from? Have you seen the XY plane? This side in the Y, this side you have the positive part, right? This side you have the negative part. This one points the side, like the upward side, where these are the positive numbers, right? And this side where this one's pointing downwards, we have the negative numbers, in case maybe you are wondering where this comes from. So in case maybe you're struggling to remember, I'm sure you all can remember this, right? Yeah, because you've been learning this since day one. So just know that if it's pointing upwards, since on the XY plane or on the Cartesian plane, the positive numbers are found this side, which is upwards, right? So if it is pointing upwards, it is positive. If it is pointing downwards, where the numbers on the Cartesian plane are negatives, it means that even it is going to have a negative spin number. So this is it. Okay? So now that you know the quantum numbers, these are the only quantum numbers you need to know. With these, you are now able to describe, we can describe any electron. You can describe it. You can track it using the quantum numbers. You can track it. The same way they can track you, Zikta can track you by just knowing your location. They can track you. They can track your phone. Now, when it comes to tracking, we are going to also talk about the IP address. Every device has got its specific address, which they use to track. Now, for you guys who are studying computer science, I don't know. Oh, there's no computer science in chemistry, right? My bad. Okay, at least you've learned something. But when it comes to tracking, your device has got some sort of an address that is unique. Every device has got an address. So that's what they use to follow you. Okay, it will direct them where you are. You can't even hide, unless maybe you throw your phone. Now that's a different case. So the same way Zikta can track you, even you can track the electron in the orbital, and you can, no matter how many they are, you can just go directly that it is you that I'm looking for using the quantum numbers. Okay. So I'm sure now. Let's look at the hierarchy. Let me just try to revise. So the hierarchy. First, I say that we have an atom, right? Then we have the shell. So you've known the quantum number to use to describe the shell, right? It is the principal, right? The principal quantum number. And you know that if I want to describe the subshell, which is found, the subshell that is found in the shell, what do you use? You use the angular momentum quantum numbers. Angular. And you know that if you want to describe the orbital now, you use the magnetic, right? Magnetic. And you know that the electron now, when you find it, you can now describe it further with the spin, right? By describing whether it is pointing upwards or downwards. So have you seen the use of each quantum number? Have you seen how important they are? The same way your plot number is important. The same way knowing your location, your district, your province. That's why when you're applying maybe for a job or when you're applying at the university, they had to ask for that so that they can know who is applying. If maybe in case of any issues, how can we track this person? Okay, that's why they ask for that. So even you need this. So now maybe they'll be asking you to write the quantum numbers representing maybe the second electron or representing the third electron. They will maybe just give you like a random electron, and they want you to use quantum numbers to describe it. Now, how do you do that? Let's now try to put everything together now. Okay, let's put everything together, then we can call it a day. So let's say you have 3p, right? We know that 3p is going to have how many orbitals? 3, right? Now this might be a case whereby they have given you an electron configuration. They can apply it in any ways, but you need to just understand this concept. You can answer any question. And try to watch the lesson where I've already taught, if you have subscribed to my videos, I've already taught the electronic configuration and how you can answer questions there. But this is like the introductory part where we apply this. So now let's say we are having, and this is how we arrange the electrons. You don't arrange like at the same time you arrange to know. First arrange one in each, then if there are some that are remaining, then you can go through again and fill in the remaining spaces. So let's say they want you to describe, maybe let's say this part, this one. You know that this is 3p, right? How do you describe this one? So you follow this format: N, NL, ML, and S. This is the format that you should follow. So first start with the shell, like the principal number, which is in front here. So no need to think too much, just write 3, comma. Then L. L is representing what? It is representing the angular momentum numbers, right? The angular momentum numbers. We just use them to describe the subshell. This is the subshell. No, I mean, the subshell is this. Yeah, this is the subshell, and these are orbitals, yeah. So now, we are talking about this subshell, the whole thing here, which is represented by the letter P. P represents which number? That's why you need to know those numbers again. You need to know both the numbers and the letter. That represents each, okay? The way they represent one another. So P represents 1, right? So I'm going to put 1 here. Now, I have ME, magnetic quantum numbers. What do they represent? They represent the orbitals, right? So I'm going to try to come up with them. If you want, you can show your work. If you want, don't. So since my L, I know my angular momentum number, it is 1, right? Which is this one. So what I'm going to do is that I'm going to say I need to come up with the number for each orbital. So I'm going to, if you want, use the number line. If you want, just that -1, 0, +1, where this one represents, this one has got -1, this one has got 0, this one has got +1. So I know the number of each orbital, but I'm interested in which one? In this one here. This one. We're describing this one, right? So I'm going to put 1 here. Have you seen? Following this format. Now I reach at my S, my spin, or if you want, put a small letter P. Your spin quantum number. So now ask yourself, is this pointing upwards or downwards? If it was pointing downwards, it would have been -1/2, but it is pointing upwards, it's going to be +1/2. You have described. So maybe suppose I wanted to describe the one that is pointing downwards. And now this one, it is in the first subshell, right? So I'm going to say, I'll follow this format. What is my principal number? It's the one that is found in front. Always know that. So I'm going to put 3, comma. What is my angular momentum number that is here? My angular momentum number, which is representing the whole subshell, it will still be the same, right? It will still be 1. But my magnetic quantum number will be different because this time it's in a different subshell. I mean, different orbitals. This way to be mixing them up. So this time it's in a different orbital. So the orbital that is having, we have found E. We have found that it is having -1 as its orbital number, right? I don't know if it's the orbital identity plot number. Yeah. So it is -1 I'm putting here. But this time it is pointing downward. So I'm going to put -1/2. You have described. Now, if you want, you can use this format. But if you want, you can be showing. Okay. Actually, what you should do is this. Like, try to be showing. Show like n is equal to 3. Okay. I'm showing you how you should be representing your work. But follow this format, or at the end, conclude with in this format. And then, followed by L. You say L is equal to 1. Then you say ML is equal to -1. Then you say S is equal to -1/2. Then finally, you conclude. You can say, therefore, -1/2. Have you seen? This is how you apply the quantum numbers. So this is it, guys. Like, this is all you need to know. I know maybe there are some other concepts about lessons which I've already taught how to draw the orbital diagrams. I've already explained. I've explained how to draw the how to come up with the electronic configurations. I've broken down the electronic configurations. Okay, I've broken them down. They have their own lessons, because if I combine with this lesson, it's going to be very long. So this is all. I don't know if you are struggling, but I don't think you find somebody who's going to explain quantum numbers like this. Maybe maybe they might be, but I've tried my best. Like, maybe like in my power, I've tried to simplify. Yeah. So I hope you have understood, and see you in the next lessons. And make sure that you subscribe to the YouTube channel, so that you can be getting updates whenever I upload educative contents like this. And if you want to join my lessons, I have a platform where I've already recorded the lessons for biology, chemistry, math, and physics. I've already explained like everything. All the topics have already been explained. NS topics of general chemistry, general physics, standard mathematics, and general biology. Yeah, you can contact me on this number, or on WhatsApp. Actually, text me on WhatsApp. Yeah, so you're going to access all the video lessons. Yeah, like the full package, where I explain the same way I've explained here. This is how I explain, guys. So your friends are enjoying, and make sure that you be part of the platform. So make sure that you subscribe. Okay, don't forget to subscribe, especially if you've reached this far. Make sure that you subscribe. I repeat, subscribe, and have a very nice day. Okay, guys, so this is our platform where you access our materials. So you access our video lessons. So just click on videos, then depending with the term, if it is term 2, you choose the course. So we have math, all these topics, the videos are here. In chemistry, all this has been taught. So there are full lessons for thermochemistry, all these lessons. And there is even atomic structure, periodicity, chemical bonding, organic chemistry. All the video lessons are here. All these are the video lessons. Even documents. We have solved materials. All the materials are here. Okay. So all you have to do is subscribe, and you access all our materials. Okay. So make sure that you subscribe, so that you can access our videos and our documents on our platforms.